but they reward people for doing.
Yeah, cool. Good evening. Hello. Hello, everyone. I'm John from the Data Lab. A few quick announcements before we get into the main talks. The Data Lab hosting our series of events over the next while. There's one in Edinburgh, if anyone's interested. Essentially, you might know already, the Data Lab have an MSc program. Within that, we fund 155 master's students. They each do placements, and we need companies to provide placements. If you're interested in getting involved, your company, maybe provide a placement or something like that, come along to our information evening, ask your questions. I'll be here this evening if you have any questions around it. If you're a university, you're interested in getting your course involved in the MSc program, any questions are just give us a shout. I'll pass over to John now. Another quick announcement.
Thank you very much. I've very kindly been given 2 minutes of your time to tell you about an event I'm doing next week, which I'm organising. It's going to be the first Edinburgh, indeed Scotland, Ultrix user group. Most of you have probably heard of Ultrix. I will show this at the end. You can snap that QR code to get the Eventbrite info. I wanted to give you a very, very quick demo of why we might use Ultrix, so I needed some inspiration. It's actually on Wednesday, day before Halloween, 5:30 in the business school. Outside, there's some bikes with Just Eat on them. So I went to their website, and it turns out you can get all their data. So I grabbed it in CSV, and I did this. If I can just click play. So these are Just Eat bike rides, aggregated by time for all years, all weeks, all days. So we're now getting to 10 in the morning. You can see some interesting patterns with Portobello and Cramond. Now this is a bit simplistic. I'm just plotting straight lines between the pickup and the drop-off points. Nevertheless, as we get into the afternoon and evening, it starts to drop off a little bit. You see the activity die down. It's quite a nice little fun, compelling visual that I started yesterday afternoon and finished in 2 hours. How I did it was in Ultrix. If you've never seen it before, you get to drag tools onto a canvas. You get your data underneath. You see the results. You can configure it. I'm not a very good programmer or scripter, but I can do quite advanced things in Ultrix. And that's why a whole bunch of other companies are starting to use it. At the user group, we are going to feature Bailey Gifford, who are massive users. They've got server license, got HSBC coming, PwC, Standard Life Aberdeen Assets, NHS Lothian, and a few other folk from the University of Edinburgh. If anyone here has used Ultrix, if they're interested in why other people might be using it, do come along. That link will take you to the sign-up page. Everyone's welcome. There will be beer, pizza, and inspired by tonight's cider. That's all I have to say. Speak to me at the interval as well if you want any more info on the Ultrix meetup. Thank you.
Cheers.
Hi, just a quick announcement. If you know, hands up if you know who Product Forge are. Okay, a few who don't. Right, Product Forge, we're live streaming tonight. Product Forge organise, the main thing we do is organise hackathons. And our next hackathon is next year. It's February the 20th, but we're doing the shout outs now because it's an annual health hackathon. The event this year was Europe's largest ever health hackathon. So we're expecting over 200 participants. We'll have data analysts and healthcare professionals. We'll have designers, software engineers, data scientists, entrepreneurs. So if you're interested in health, in digital health and care, and if you've got any ideas around that, then if you want to check out the event, it's at productforge.io. You can follow us on Product Forge, and the early bird registration is open just now. Thank you very much.
Okay. Right. Sorry, I'll just get my set up. Went to sleep. 2 seconds. Right. So I just switched to HDMI. Oh, it hasn't done this slideshow. Yeah, I had that set up before. Slight technical issue, but there you go. Yeah, so welcome. I'm Angus Nielsen. I'm a technical architect at Wood Mackenzie. I'm currently working on the data platform. I joined them about 2017, December. I was going to do a little bit more about, so I'll go back to that. So essentially I've worked in kind of various aspects of data over the years. And it always kind of seems to come back to somewhere or another, it's about the data. And I would class myself as a data engineer, not a data scientist, so probably in a room full of people that are predominantly data scientists. So I see my job as probably the plumber that builds a lot of the bits and pieces that you need to do your job. And that's what we're trying to enable at Wood Mackenzie. We're trying to enable a kind of a complete data platform. A quick mention, because I always plug this as much as possible, mention for Bite Night. If people haven't heard of Bite Night, it's basically a charity that originated in the tech industry, and every year I sleep out for one night, give up my bed. I think we're fortunate in the tech industry. We're well rewarded for doing something that most of us probably actually find fun. So this is a little bit of giving back. That's also, I will share the slides at the end of this, and my Just Giving link is there. I'm trying to get to 1,000 for my particular thing, because my company will match, donation match as well. So every pound you put in counts as £2. So anyway, that's my quick plug for the charity. Okay. No surprise, we're recruiting. We have a couple of our fine recruitment people at the back there as well. We're looking for all kinds of people from all a broad range of skills. And I can just say personally, I think with Mac there's great opportunities to learn and develop. They're great at supporting you. They have a good, I think, work-life balance, very good benefits packages, all these sorts of things. But I'm not a recruiter, so speak to the recruitment people and they'll tell you all that. But from a personal experience, I've found them a great place to work. So, just quickly, because I was quite interested in this, how many people have heard of Kafka as a technology? Good number. How many people have heard of Kafka as the author? Yeah, almost everyone. So it's still, although if you Google search Kafka now, you will tend to find you will get Apache Kafka before you get Franz Kafka. And of course, I've used Metamorphosis, which I had to study at higher English, the name is nowhere relates to the actual technology, but what I felt was that I would kind of have a look through some of the quotes to see if I could find something nice and inspirational from Kafka, forgetting, of course, from everything that I'd learnt when I studied Kafka at higher, is that he's actually quite a depressing guy. I think one of his best ones was, there's an infinite amount of hope in the universe, but not for us, which kind of, it kind of reminds me of, I don't know if you saw recently the AI quotes that were being AI generated, things like before success comes slaughter or things like that. So he's probably in a similar category. But I did find this one, which, by believing passionately in something that does not exist, we create it. The non-existent is whatever we've not sufficiently desired. So, and we're all in the business of creating, so that was quite good. It did still feel a bit angsty and a bit kind of desperate, but If you read anything about Kafka, the person, which I've ended up doing randomly quite a bit, then yeah, that was who he was. So that's fine. So what I'm going to cover today is kind of basically who we are, what Wood Mackenzie is, our journey so far, some of the key technologies, and kind of where we're going next. It is a fairly high-level overview. I'm not going to go into too much technical detail, but I'm happy to discuss and chat about as much as I can. Who is Wood Mackenzie? So headquarters in Edinburgh, based and founded in Edinburgh since the 1920s, in fact, as a stockbroker. But in the 1970s, when they discovered oil, that's when the company kind of went through a major transformation and became a kind of global data company, understanding the whole of our natural resources markets, from chemicals, metals, through and energy, and everything that's sort of kind of associated with that. And obviously now a big drive towards renewables, which is an important part of our analysis. And we're quite heavily involved in companies understanding how they can move from carbon dependency onto more sustainable future. So exciting time to be involved with and apply data to these kind of problems. But at the heart as well, it's also now a tech company. And the sort of recent few years, there's been a drive towards making it a technology company in itself, with the sort of modern technologies that you would expect. Obviously, it has a reasonable amount of legacy systems, and that's to be expected for any company that's been around for any length of time. Actually, probably any longer than about a year, and you will have effectively legacy systems, the rate that things are moving. Push that as well in terms of we're a tech company. We're now really love technology. We host all these different events, Kafka Meetup, really, which I'm talking to you about just now, PyData, another one we regularly host, and cybersecurity. Mention of Girl Geek Scotland as well. I think they've got a competing event on tonight as well. I have to have a word with Sam about that. And we've got coming up next week as well, ThoughtWorks, Tech Radar. We're hosting their latest event as well. And we have now a Twitter handle, which rather surprisingly the company's given me the password and login to as well. So watch out. You see some random tweets that make no sense. That was probably my fault. So kind of part of it is what the problems we're trying to solve, and you're all, you start researching and everyone talks about the 3 V's, and then suddenly there's another one and someone adds another one, and that's, that's the way these things go. And these are fundamentally the kind of a lot of what we are trying to deal with. Variety is our biggest challenge. Wood Mackenzie deals with data sources from all over, kind of spanning multiple domains. As I said, we're looking at natural resources, but obviously, there's a difference between copper mining and understanding oil and gas production, to understanding energy production, wind farms, and then merging all of that with global economic data, exchange rates, global forecasts for all these kinds of things, all impact on our data models. So it's variety is one of our biggest challenges, and that's kind of where we're working. We also work a lot with geospatial data, and again, increasingly things like satellite imagery, to establish interesting data from stuff that we can't extract from other sources. And of course there's veracity. This is one of them. So one of the key decisions we were having to understand was ultimately a lot of very large, high-value companies depend on our data. So being able to explain where our data comes from, the end-to-end process and how it got there, is quite important to us. They come to us and say, well, you've given us this figure. We've just bought a company for $3 billion based on your valuations, and we want to know why you came to this valuation because it didn't quite work out. Then it's good to be able to at least give them an idea of how we got there. And that's something that's quite difficult to do in traditional kind of standard database systems. We've also got things like velocity, volume. As I said, we don't have a massive volume of data, but we do have, we wanted to increase the velocity of that data. We want to get the data through as quickly as possible. A lot of it's financially sensitive. The quicker we can get the data out there, the better. But also IoT data. This was always part of the plan for the company. we wanted to start getting involved more in that, in sensor type data and these kinds of things. It's now a reality. We've just recently, it's been announced, we've acquired Genscape, and that's a company that specializes in IoT, so that's going to become part of our data set as well. So it does all kinds of cool things. The coolest bit, me being a sad geek, the coolest bit of it for me was that we do things like tracking shipping. So again, that kind of illustration thing that I saw earlier looked quite cool. That's the sort of stuff we want to be doing. Showing where everything's going. And value is kind of, again, we're not a startup where we're trying to understand how to monetize what we have. We know we have a very valuable resource. We have a large number of very large, high value companies that are prepared to pay for the data. But also what we need to do is remain competitive, and we need to understand that we're able to solve the problems they want now, not just what we were solving 10 years ago. And when you start to understand legacy systems, this is kind of the problem you have. Is you come into companies where they've been around, and they say, right, okay, we've got a problem. We build a database, and then we load it with some data, and then we have clients in the front end, and all's good. And then you say, right, I want to manage that data, so I do something there. And then think, oh, we've got a different data set, so we do the same over again. And then we build that, and we connect that management system in there because we don't want to develop a new front end because it's maybe too expensive at the time and it's quicker. And then you buy a company, and oops, got another one. And then some of your clients want to look at some of the data in one of the other databases, so you build something perhaps quickly that you need to do to deliver that customer value. And then the people managing that piece of data want to also manage some of the data in one of the other systems. And then someone wants to synchronize that data to some other system. And then someone wants to synchronize back to that database to make sure it's in sync. And then somebody decides that they're going to load an Excel spreadsheet and they're going to kick that in somewhere, and so on. And you probably, if you've worked in any kind of enterprise organizations, this is a very common picture. They will not have a single database for everything. And it's fine, and it works, but there's a lot of kind of hard work goes into doing that, and that hard work distracts you from delivering the end goal. And again, you kind of, to break that cycle, you have to kind of do something a bit more innovative. And also, we're all human. I'm a big fan of this particular cartoon set, and I'm sure some of you are, and if you're not, check out XKCD, because it's always got a few interesting takes on data. Yeah?
Sorry to interrupt, but I don't think your microphone's
Oh, it's good.
That's for the live stream.
Okay, it's working for the live stream. Okay, good. Sorry, I thought it was a microphone for the whole room, so I'm sitting here talking. I will try and talk up a bit. Sorry, apologies. So we wanted to understand, and I'm an engineer, but we also still sometimes do some research. So we decided to go and try and understand the problem. And this is a key proposition. Martin Kleppmann, if you haven't seen or read his stuff or his works, I highly recommend it, because he has kind of changed a lot of thinking in terms of the way that data and database systems operate now in the kind of modern world. And one of the key points as well is that the kind of the patterns enable us to migrate legacy while supporting business as usual, which in a commercial environment is key. We're getting paid a lot of money by our clients. We can't just suddenly say, right, we're going to just refactor this whole database, turn it off, and on we go. In an ideal world, you could do that, but you can't, because you have a revenue stream, and that's what's paying your wages. So you could do that, but you won't be on a job for very long. And Martin Kleppmann, he has strongly advocated Kafka as being an ideal technology to implement his ideas. It doesn't have to be Kafka, but I think Kafka is, you're finding, is there. And Kafka, where it come from, LinkedIn originally developed it, open sourced it, Apache. It's written in Scala, Java, and it provides this high throughput platform handling real-time data feeds. And as I said, that's not necessarily the major objective for what we're doing, but this is kind of one of its key selling points. To understand really, what's important is it's fault tolerant. It makes sure your data is saved. So it provides you effectively your transaction log. So what you're saying is I'm taking my entire transaction log for all my systems and I'm putting it in one place where I can save my data, and then I can worry about how I materialize that out later. And this is a very powerful pattern, I believe. It's run on clusters. This is all the sort of how it's all set up and the sort of technology of how it is. It's completely agnostic as to what data you put in it. So you can put JSON, Avro, but essentially it's just creating on bytes and a key. That's it. You can put image data, put all kinds of things. I've spoken to people, that, for example, that are putting radar telemetry data in it, and other people are putting, messages using a message queue. You could be getting clicks through from your website. It doesn't really matter. It doesn't care. Completely agnostic about what's going into it. And you kind of, there was this, is it really scalable? And these are some stats that are floating around, but I mean, the Netflix one are now claiming to put in the region of 500 billion events per day through using Kafka. Again, if you look at the companies that are buying into it, and if you're working in data, it's almost certain that you're going to run up against this technology at some point. As I say, all the, Uber, Airbnb, all these big names are using it, but also there's a good number of companies around Edinburgh that I know of already using it from all sectors. And it kind of it gives you a certain confidence because you're in good company. You know that then there's going to be maintenance done on it. It's not some project that someone's forgotten 3 years and then you're going to try and figure out how you're going to patch it, which is kind of a key technology. So once we'd looked at this and we'd understood, that this looked like a good fit for what we wanted to do, then we kind of had, there's this high level view of what we wanted to do, and this was, pulling in all our existing concepts. So we've got things like web scrape data, which is key to a lot of what we do. Existing databases that we have and want to integrate with. All of this is possible, and Kafka being our central hub, effectively our message platform. We can then materialize that data out into analytics platforms, whatever that is. Kafka is again agnostic and provides a number of really good tools for getting your data out. We can manage the data with the stream processing. So it's basically this can apply logic. So as soon as you can apply logic to your data, you can apply anything. Machine learning, it could be as simple as I'm fond of telling data scientists, it's just counting things really. So it's quite good at doing that, but you can do all kinds of really clever stuff. And again, you can pull out, we can look at building things like we've got data warehouse, now data lake is the fashionable name, but again, very easy to materialize out. If we want to provide a data lake for somebody to do some kind of more batch-based processes using pick your technologies. I'm sure you guys know it better than I do on some of those technologies. Yeah, certainly, sorry. And I found a positive quote from Franz Kafka, paths are made by walking. And that was kind of what we did. We kind of, for all the reasons detailed already, and we went for use that horrible quote, move fast, breaking things, and went for it. Again, another one of my XKCD cartoons. I'll just let that settle in. Yeah. Doesn't always work, and we did break things. It's not a linear process. You do go through reinventions of things, and you try and work it out. We applied it initially we started with one small section of the business, one particular business case that we had to start to build our platform. We weren't specifically, from a technology point of view, particularly bothered, but we selected a case that made sense, that was also an opportunity for growth for the business, but it was also perhaps a lower risk, but gave us the option of trying out various things. And the kind of key thing was the ingestion of the data, so building a scraping framework that would then allow us to pull in all these kinds of bits of data. And again, it's a very mixed picture. United States has everything from as I say, HTML we've got there. EBCDIC, anyone heard of EBCDIC? Yeah, I'm noticing it's probably, without being biased, it's probably the people with more of the grey hair. It's basically, essentially, if you're saving data in a mainframe, that's how you'll do it. Not too many of them in modern data world, but the old school world and a lot of legacy systems still there. So with that, even OCRing documents. Believe it or not, we're having to deal with documents that have been basically scanned in as PDFs, that kind of stuff. So there's interesting challenges there and interesting challenges from a data science point of view. So this was the web scraping. One of the problems that we run up against as well, which kind of is important later, is that you need specialist knowledge of this data, though, to do it. It's not kind of perhaps like, I would say, not trivializing what they do, but for example, Skyscanner, most people can probably go to a website that's booking flights and understand what they need to understand from that within reason. But this is very specialized domain knowledge as well. You need to understand terminology and whatever. So how can we build a platform that works for that and move as quickly as we want to move? So some of the building blocks we used, AWS, pick your cloud provider of choice, but our parent company, Verisk, is very heavily invested in AWS. AWS was our natural choice. They have a lot of knowledge and infrastructure already built around AWS. The strategy is where possible is to use serverless. Again, perhaps a technology that's not necessarily something you need to worry about from a data science point of view, but this makes things simpler to maintain and run and operate. And the other main building block, core languages, Java, because it's the natural language almost for Kafka. Python is the language of our data, essentially. That's our approach is predominantly to focus on Python as our data analyst's language. We do use other languages for various things, and again, Kafka gives us a good separation of that concern. Kafka doesn't care. So kind of other key technology which I'll mention is Kafka Connect. Kafka provides us Kafka Connect. This is a very powerful technology because it allows you to essentially just specify a connector and push the data out into any data store that you want. Now obviously you have to have some understanding what schema you want for that, but you can push it into Elasticsearch. And in the early stages especially, that's really powerful because we just need to understand the data. We can start pushing business events into Elasticsearch, and we can start understanding what's going on in our system very quickly. And it is trivial to set up relatively from a technology point of view. So that kind of helped us along the way. When we're sourcing the data, we wanted to abstract to an extent all the cloud stuff. So we're running all of this in the cloud, but what we don't want is we don't want the people that are writing the code that requires all this, the complexity of the domain, to have to worry about how do I run a service in AWS. So we built an abstraction and a framework that allows us to, the people writing the scrapers to work on their laptop. They can write a scraper on their laptop, they can connect to the website, they can pull it, and they can see the data result locally. When we deploy it, it gets deployed in AWS and it gets run on the AWS environment. So now that we have the Kafka stood up and we have that, we can now ingest data from any source, internal or external. We actually use some of these technologies at the moment to source data from our internal legacy systems as well and push that through pipeline. We can manipulate the data to enhance and correct because we can operate within the Kafka pipeline, and we can blend old world and new world seamlessly if we want. And all of this, again, we have the audit, so the log gives us the audit. In terms of when you write to Kafka, it's written forever until it expires, and it's up to you how you set that policy and your needs are. But essentially, Kafka never deletes itself unless you tell it, I only want you to retain for a day. It will retain for a day. I want to retain for a month or forever. It will do any of those for you. Obviously, within limits of how much data volume you want to store, you have to manage that sensibly. But I'm not going to go into the details of that at the moment because it's a whole talk in itself. It gives us kind of quite a good and a very powerful technology in terms of also our scraping and our sourcing is aware of our data platform, so we can drive scrapes, for example, which allows us to not overwhelm a site. It allows us to only ask for the data we need and becomes much more responsive. So that was kind of quite a thing we hadn't really thought about when we started on it, but realized we could do quite quickly. Has been quite powerful, I believe. So this is kind of abstracted. I've done various architecture diagrams of this part, but this is effectively our first version, if you like, of our Python interface to our data platform. And we're evolving at the moment, so we're kind of going to extend on this idea, develop this plan. The idea perhaps might be that people will be working in Jupyter notebooks, developing their models, and then again deploying them out. But with this stack of technologies, the only part that people need to care about is the Python interface. Everything else from then on in, the Docker, Jenkins is our deployment tool, and all these other bits don't really matter. You're seeing everything as an abstraction from that point of view. And that gives us kind of, again, a really nice story from the point of view of the data engineers can focus on, and data scientists can focus on doing the stuff they need to do with the data, how they want to map it, how they want to understand it, or how they want to model it. And we support the platform that then enables that. And we can enable transformation, and this is kind of very current, so we're currently working on some interesting stuff with this, but to understand a stream in Kafka, a stream is essentially an abstraction over this data that's being written continuously to a log. And it says unbounded, that means unlimited size, so it will go on forever. And interestingly, there's technologies like KSQL, which allows you a SQL abstraction over the top of it. But if you do a select star from Kafka topic, then it may never end. So you have to understand that to an extent to kind of get on with streams. So just as a very quick understanding of this is an example of, here's a key with some values being written, and we've then perhaps got some aggregate table, and this is the streams. Tables are effectively a duality, and the table itself is a stream. So you can start to understand that within these little arrows as well, we can do any logic we like. Keeping an aggregate value, and then you might want to be notified of events changing on that aggregate value. So this is kind of a pattern of how the streams and tables all sit together. And you then have the concept then of a topology. Effectively what you're building is this topology of, it may be streams and tables and various bits of logic in between. And with that you can correct, validate, aggregate, all these kinds of things, map it then finally into your new model. This is your ETL process, if you like, but it also can be doing much more interesting stuff in terms of, if you insert some machine model in there, and again, a lot of the big banks are doing this kind of stuff, you can start doing anomaly detection and other kinds of cool things. So they're great for building a data transformation pipeline. I'll skip over that bit because we're running low on time. So in summary, this is kind of an overview of how we see it. We see the sort of top-level platform with a bunch of domain experts who are technical but experts accessing our set of services, and the pipeline effectively being hidden away but working seamlessly, delivering products. Quickly just point out, this is kind of a bit offline, but basically the Wood Mackenzie Lens is our latest product offering, and this data is designed to, being designed to feed this. And we have live data now going into our system through our pipeline. It's obviously at the moment it's a blend of legacy and new stuff, but we were able to bring in a very new kind of pipeline of data very quickly because the new platform structure allows us. I'll just kind of move on to, I've put this, and again, I'll share the slides, so that's fine in terms of some further reading. And just to finish up, final word from Franz Kafka. And I kind of feel we tried to follow this approach. We could have went down an approach of just working with the databases that we had and trying to mangle something together. But we stepped back and said, let's try and do this right. Let's try and engineer it. And I think the pace initially is slower, but in the long run, you get there. You'll get there faster. And again, my favorite cartoonist. Questions? I love this cartoon. It's a slow burn, but you get there. So that's it. And I'm 29 minutes and 33 seconds. So. At least I've got the applause for being on time, because believe me.
Anyone got any questions for Angus?
Yeah.
I like a question.
Yeah. Sure.
You talked about that you were looking at a legacy system and you're implementing a new framework, which is
Yeah.
the Kafka framework. How did you do that? Did you just create your first user case and then build around that Kafka and then gradually over time migrate onto a target?
Yeah, pretty much. Yeah, I mean, we basically started with one particular. We had an existing system, so a legacy system, but it was relatively new. So it's actually one of the newer technology platforms, and we tried to essentially, in the very early stages, almost emulate a startup to say, right, we're a startup. We're looking at their product. We want to compete with that product. How do we build that? So there was a small group of us to start with, which has grown now into massive a number of people and forever growing. But that was the concept, and we then, but we had the access to the business domain specialists, so we could get them to define the logic. We ignored completely the existing code base for various reasons, one of which was we didn't want to go completely mad. It was, any of these systems had grown lots of arms and legs over time, so we kind of wanted to take a step back and just understand the business requirements over again and start building from there. But we worked closely with the domain specialists in the teams, and that's where we built out the framework as well and understood if they could start working with Python and could they start coding up scrapers in Python, for example, and they did, and they're now, we now have a team, in fact actually mostly in this case based in Houston, who are maintaining and running these scrapers, fixing them as we go. It's not fully finished, but then I've probably never worked with a system that's ever fully finished. None of them ever are.
So was the first use case, was it a new use case or was it an existing
No,
use
it was an
case?
existing use case, but actually, although we built the platform, the thing that ended up getting to production first and is currently on our front end of our platform was a completely new business case that we were then able to implement on that platform. And that was much faster because we already had all the stuff. The problem was actually the legacy stuff then when you're trying to replace an existing system is there's a much heavier load on QA in terms of making sure that you're doing exactly the same as the existing system so people don't miss out. So sometimes then it can become a bit of a millstone around your neck, whereas the new stuff was implemented very quickly. We brought in a separate team, they were able to operate on the platform, and they were able to deliver a kind of real new value to the business very quickly on it. A matter of a couple of months, I think, really 2-3 months, and it was there. So it kind of proved out what we were trying to do.
So did you have clients that were using the new product set and the old product set concurrently?
We mostly switched out, so which was a very good thing, is that basically the new product front end currently uses a mixture now of legacy and new data. But we switched all of the existing customers for that product onto the new product. We were able to basically push the old data in initially. Again, that's being done all on AWS, but it was kind of quite, that was done fairly early on so that you could develop the front end. And the front end itself, I'm no credit for that. It's a fantastic looking front end. And the guys that worked on that have absolutely done a fantastic job. If you look at it, it's kind of got attention of some of our suppliers are wanting to use it as a kind of core example. We use Mapbox, for example, and Mapbox are actually kind of keen on using us as a reference client for some of the work they've done on the mapping side of things. So really cool. It looks cool. Lots of maps. They always look cool. Much better than pie charts.
Did it all go smoothly, or did you have any challenges to overcome?
Yeah, lots of challenges. It's always the technology, less so. The technology tricky, but where are my tables? Where's my entity relation model? Why don't I have that? Why can't I do a select star from here? kind of stuff. That kind of mindset change took kind of longer. There's a few dead ends technology-wise, things we went down, especially trying to understand not so much Kafka. Kafka we kind of had up running and it worked. It was kind of probably the, not thanks to me, but we had some good kind of engineers behind getting that up and running. But the kind of problematic stuff was we were using some fairly new technologies, for example, Fargate in AWS, which is running Docker containers, and trying to use serverless, finding that it didn't quite meet the needs, so we had to back off some of the ideas and try and be a bit more pragmatic. So yeah, nothing ever runs smoothly, but then yeah.
You have to use serverless.
Well, you could argue we use Fargate, which is serverless Docker. So we're using Docker, but we're running our containers as Docker rather than, for example, using Lambda. But Lambda isn't really a very good fit for scraping because processes can run quite a long time. And although you could do some clever orchestration, it was just too much complexity. And it's kind of a trade-off between complexity and whatever. And I've got Fargate as a environment. Everything stopped except the Fargate containers because the underlying EC2 instances are being run by Amazon, so they couldn't shut them down. So the scraping framework, it was pulling and ingesting data, was fine. Everything else was down, but you learn by these things. So and that's why it gets applied in dev first. So you get shouted at by all your developers first before. Yeah.
Does Kafka plus the inbound ETL in whatever Python plus the outbound ETL rather than just go straight for Logstash?
No, if you wanted to do that, but our Elastic is only one. I mean, we're actually pushing into a number of data stores. Although I would say that one of the things we had discussion recently was around upgrade of Elastic, for example. So we want to upgrade our Elastic instances. And the people on the front end are talking about Elastic that they use as the back end for our product. We're saying, well, how will we manage this? And I said, it's fine, just spin up the new cluster. We'll just replay the Kafka log straight into the Elastic cluster, and then you can swap them over. We didn't have to worry about that. It almost just becomes one of these things that you can just say, right, we'll do that. And that kind of is a much nicer story. But also, somebody wants it as a database. They can have it as a database. If we want to materialize it out into Parquet on S3, so someone else can go and play with it in another technology, it's the same data they get. So the kind of concept is that Kafka is our source of truth. Our data is stored and is there forever, persistent, for kind of values of forever that we care about. In other words, it's not necessarily we keep everything everywhere. That would be mad, but we keep all the data that we care about, we can keep for as long as we need, and then if we need, we can replay it. And again, yeah, the pub sub is kind of, Kafka can be used as a pub sub mechanism, but it's not really what it is. It's really a log. It's just a append-only log, highly optimized and very fast, very performant. I mean, we saw that even with mistakes we made where we some random code that went off and punted 1.5 billion messages onto one of our topics, and Kafka didn't blink. If you'd done some kind of recursive silly thing in a database, your database probably would have fallen over, or you get all sorts of warnings. Whereas Kafka just went, "I'm sure you meant to do that. That's fine," and just coped with it. And that was we're not running massive instances. It's very efficient because it's so simple. It's not trivializing what's done. I mean, to make something simple and efficient and work well is a really difficult job, but it's trying to do one thing well generally. So interesting stack. Yeah. Yeah, I'll hang around for a wee while. Absolutely, happy to. Right. Yeah. Oh no, thank you.
Hi everyone, good evening. Thanks so much for having me tonight. My name is Anastasia. I'm actually working at the University of Edinburgh at the moment. I'm teaching statistics, but actually looking for I'm very interested in analyzing complicated data, and in my PhD I focused on generating insights from big data from smart meters. So today I'll be talking to you about little examples I encountered and how I tried to sort of generate insights from very complicated data in such a way that not that they just make sense, but also the solutions can be stable. And in my experience, I work quite a lot with people who are actually not data scientists or often don't even understand basics of numbers. So my aim and interest is often about making data science really easy, but also making sure if I provide insights to someone who wants to understand data, that they can actually replicate that or understand why this model predicts well. It's really hard to do that. So today I'll talk to you about this and explain to you challenges I have. But you all agree that big data is certainly quite promising, and many people talk about this. It's great to see there is more infrastructures now to actually process this data. But I think we're still not really sure how to approach this data. We have certainly a variety of technical solutions how to store it. But when it comes to methodology and techniques, there's quite a lot available. And if you're not really sure about what the process in your data is, it may be quite challenging to find where is it to start. So today I'll present to you a couple of challenges, a couple of examples, and hopefully give you a bit of space to think, you know, how can we train better, maybe about analyzing these types of data, and what can we take for the future of data science. Before I start talking about the examples, I want to also leave a quote. It's a bit longer than Kafka's quote, but it's a quote by Bremen, who I think contributed quite a lot to machine learning literature, but he also worked as data scientist for a while. And one of the things he brought, I think, from his experience in industry is that we really need to think about data before fitting any models. And although models are really exciting, it's really tempting to fit very complex model, but not necessarily think whether it solves the problem we need. So today I'll try to address both, and hopefully you'll take this quote with you as well and agree why this one is really relevant for today. What I'm working with is smart meter data. I think smart meters got quite a bit of attention. But if you aggregate this data and you present as a simple graph, it'll look like something like this. So this is just a simple box plot which plots the median use or center of the use, and you can even though there's so many points, you can recognize double-shaped peaks you have. So you have, imagine if this was 12 hours of the day, you have quite intense consumption in the morning and the evening. So this is really classic representation of how people consume energy. And that's something you'd really hope to find in the data as well. If it's broken down, you can find lots of profiles. If you just look at 12 hours of a day again, you can find, for instance, someone who is full-time employed, someone who stays at home. So you could trace a lot of activity from these types of data, but the challenge may come if you're actually trying to understand quite a lot of people at the same time and a lot of patterns. And unlike some other customer data, like, for instance, Netflix, I think, this data is dynamic, so it has something going on in every single second. And unlike Netflix, sort of when I thought about the differences as well, you know, you may have a single activity a day, or you may have certain quantity of activities which can be used as counts. When it comes to this one, if you really want to generate useful insight, you really may want to understand the whole dynamic, and you need to consider the shapes together. So today I'll talk about 4 kind of very common tasks data scientists often do when they get the data, and one of them is clustering or segmentation, another one is forecasting, and then I'll show you an example also of classification, and I will also talk a little bit about the problems with data and computation and how important it is to actually preserve also anonymity of our customers. I'll use a bit of mixture of statistical learning. So if you don't know much about it, that's totally fine. I'll be happy to point you to kind of key things in the interval, but I'll try to keep it as simple as possible and give you more about insights rather than techniques. And what I want to focus as well, that I'm not just interested in prediction, I'm not interested in high accuracy of my models. What I'm really interested is understanding why accuracy is the way it is, and can I actually apply the same methods to a different data set? Would that be stable if I did that? So what I'm going to talk about first would be clustering, and I want to give you an image of the scale of data I'm looking at. So in my case, I worked with about, I think, 16 billion of observations. So it's quite a lot, and that comes because you have lots of records per day. So you have 48 records per day, and if you have hundreds of thousands customers records for the whole year, it's really, really lots of data. So one of the approach would be, of course, is to try to cluster it or segment it or aggregate. And what I want to show you today is when you aggregate your data, you may actually lose anything interesting about what you care or want to understand. So what I did, of course, because I have quite a lot of data, I provided two samples. One is aggregated, and the other one was just a random sample I took of this aggregated data, and I was trying to see, would there be any differences? Shall I use aggregation as the way to reduce my data set? And if you know anything about principal components, this is just to illustrate the difference between the two. We have aggregated and disaggregated samples. And if you look at the aggregated case, you can already see how all shapes kind of come from very, very similar density. But let's make it a bit more visual. So what I'll show you today is first, this is the clusters you get on the aggregated sample. You get 9 clusters of energy use. And if you just look at the shapes of the lines, you could say they are quite similar. And if you analyze the UK and you think, what, could there actually be 9 types of customers? There is so much more dynamics should be provided in smart meter data. So what happened in aggregation, because we put everything around the center, all the extreme values collapsed, so we don't really know much about diversity. If you disaggregate your sample and you try to do clustering there, you actually get way more diverse picture. You can see more activity, you can see more outliers activity, you could see patterns of no activity. And I thought that was really interesting. And that's something I only found by experimenting with it. But whenever I went to any presentation, people always say, oh, I aggregated this. This is my aggregated result, which I think would be relevant if you really care of macro picture. But if you're trying to understand individual dynamics or predict individual use, I think that's an important observation to make here. And when I was trying to put those clusters on the map as well, I actually struggled to find any spatial dependencies in there, because they appear everywhere just because there is diversity of customers, there is diversity of patterns. And when it comes for me to actually make sense of this data, that's where the challenge came through. And my advice kind of arises from that, that maybe depending what you want to understand, you'll be actually clustering within clusters, because what I did after that, I removed some clusters which looked very like outliers, gone in, found more clusters. So as more diversity of data presents, you'll find more and more diversity within each cluster. And the methods I use is Gaussian mixture models, and I used K-means, which was quite standard, I think, tool for this, computationally way less expensive, but it gave me only one cluster. It's literally collapsed. So the challenge here as well, can you actually use the models which may be more prescriptive when we look at data science literature, for instance? What I want to show you as well is that given this diversity of the data, we can actually have more advantage when it comes to classification, because if you have a high granularity, maybe you struggle to cluster, but you can classify with more precision. And what I've been focusing on is fuel poverty or energy vulnerability, something which people quite care a lot, I think in Scotland especially, because it's quite hard to find customers who are fuel poor and may need the support. So I spent some time trying to figure out, can one, just by looking at dynamics in time series data in smart meters, identify potentially problematic customers? And this is just slightly boring overview, but this is the data I've been working with, and I had this vulnerability flag which I created myself, which was coming from understanding if customers were receiving any financial support, and I was trying to understand were there differences in dynamics of their energy use. And when I look visually, there was no differences, which I found fascinating because visualizations is always the place where we start. And if you look at things overall on a macro level, you actually won't see much. But I used random forest, which comes from Bremen as well. The reason being I could interpret it to a company I worked with because it has features, feature importance component to it. So I could actually show where the contribution to good accuracy was. Still need to be pragmatic here, but if you look at my estimation results, random forest was really good reading from time series smart meter data. So it may struggle to give you good segmentation, but it can actually learn a lot about the structure. I want to stop here just to say that I'm very pragmatic, and I think it may have worked on my sample. It may have not worked somewhere else. So I'm really keen to know how it would work somewhere else. And please don't take this as a solution to one of the major problems in Scotland. Okay, this is just an experiment, and I'm certainly not claiming that this accuracy will hold if you scale that or if you introduce more data. The last thing I want to show you today, and this is again just an illustration. Of course, the most fascinating things with data like this would be forecasting. And for energy sector especially, forecasting with the minimal uncertainties is always a priority. So what I was trying to do, although there's so much methods available, and I'm sure many of you will know even more about deep learning and things which will basically replicate the patterns for you, what I was trying to do is find a model which not just predicts well, but shows me which times, which particular components of my data tend to be predictive, which features do contribute most. So for forecasting, I decided to not use any additional data as well. Simply, I don't have access to it because I'm a researcher. But I wanted to understand, can the single dynamic in the data tell you a story? And can you use that dynamic to then cluster your customers? So can you just study some on periodicity and then group them by that? And I used generalized additive models, which I found the most magical thing in inferential prediction, because we do have lots of models nowadays which can do prediction no time. These ones can do great prediction, but they can also show you why it predicts well. And I'll give you two examples. So this is my couple of experiments I did for rural residents. And if you've ever seen energy data in your experience, it often comes really nice and neat, and you can fit some very simple model to it and it'll show, yay, you can have 80% of accuracy. This is example of someone lives in a rural area in the UK. I don't really know where exactly they are, but that doesn't matter. So the red line represents the fitted line by the model, and the blue line is actual data. So the essential component of this model is smoothing. So what we're trying to build is kind of sum of multiple smoothers, which may be formed of function over time. It could be extra, but allow you to fit different components of the pattern based on combination of those functions. If you look at this, I think it's not bad, okay? Because if you actually used a very simplistic model or linear regression, you just get a line through, and I can't capture dynamics here. And in this scenario, my model explains about 60% of variation. But the issue with this is that this model will not predict if I wanted to predict stuff for next year, for instance. It's really good predicting next week of energy consumption. It'll have to be updated once again. It just can't handle more than a week. which I thought was quite fascinating, because if you look at this customer, so I tried to put 3D images as well, so you could see the daily and weekly use and how it varies by winter and summer. It's actually not really easy to model something like this or design a good uncertainty measure for this type of pattern. What you often see in literature or examples online as well, when people try to show you how to fit these models, is this type of thing. When you have a very, very clear pattern, it's double peak, it repeats itself. If I fit my model to it, it's almost 100% accuracy of prediction, and I can predict as much as I can. And the reason I wanted to show you this today is because many models I found, and when I was doing my research, I kind of didn't know where to start because not much was available to me in that area yet. When I found this, I thought, this is great, but no one showed me examples of messy data or problematic data. So it may have worked on something, but I'm wondering how well it will do in other settings, or how much one will need to adjust their model to actually make it work on any customer in your data set. This customer is really weird because they are just doing the same thing every day, which almost makes you think maybe they are a non-residential customer. It could be business, but you know, these kind of things happen in your data, and I only shown you 2 examples, but imagine I had hundreds of thousands of customers, all have a unique pattern, all have a unique dynamic. If you're interested in predicting, you know, their use, have a little uncertainty measures for each of them, I have no idea how would you do that, but I think there are ways to approach that. What I just wanted to open up is the discussion of, can we have one model which fits all? Can we actually have one approach which will fit the same data? Maybe we'll have to adjust quite a lot as we move through different components of big data sets. So what just happened? I just fit some GAMs. GAMs are great. There is lots of variations to them. I think they are almost like deep learning, but with a little inferential part. They're really computationally expensive. So while they do a great job, I hope someone find a way to optimize them. And they have problems with large samples, but they do give you good accuracy. And apart from that graphic I've shown you, you also get a very nice output where you can actually see which particular time mattered. You can break the time. You can see, are there seasonal variations? Are there spatial variations? How do they affect your results? I'll have a look what my time is. I've actually been quite fast. So I want to just summarize this, okay? I think you may have seen quite a lot. It may be almost overwhelming. I was trying to show you kind of an illustration and kind of maybe brainstorm together with you and show you the challenges of someone like me trying to approach the data like this. And the reason I have these challenges is because when I generate insights from this data, I'm trying to communicate them to governments, to researchers, to analysts, and keeping it simple but in the same time reliable is actually really difficult. And although I used very simplistic methods, which I think can be easily broken down, may not need much of resources, we do have lots of issues with privacy here. So ideally, I guess if you work in an energy company, you probably will have more data. But what I also learned that last week I was on energy conference where lots of industry people were there, and it felt to me that they actually never process the data as a whole. They collect lots of data, but they don't know where to start making sense of it either. So having lots of data doesn't mean we can make a good insights. Depending which sample you use, as I've shown today, you can find very different things. So you may aggregate your data, or you may think, I'll randomly pick some observations and then train my model on those. When you have a big data, I think we have this adverse effect. So when I was learning statistics, always we've been told more than 20 observations is great. You're going to approximate the population in the best way. So if you have 20 observations, that's enough. What we have now is billions of observations, and it feels to me that it's almost the same as having 10 observations. Impossible to make sense and may not necessarily predict us anything useful about population. It's just too much. So finding a good sample, I think, also can be a challenge. Understanding your data, not necessarily taking it all at once, but integrating data on various levels, ability to validate that, I think hopefully could make a bit more stability in any data science problem. Computational power is there as well, but with solutions which have been presented earlier, I feel it's amazing to work in your company because you probably get to analyze data without worrying too much how to do it like we do as researchers. But we do need to think carefully about the problem. So what is it we're trying to understand? Why are we analyzing this data? And often I think there is an urge to sort of feel, oh, I have this data, it looks cool, let's plot it, let's count it. But what's the insights we're getting from it? Can we use it to provide policy interventions? It's not always the case, and some of the methods we actually use often are not designed to provide insights. They're more for prediction and higher accuracy. And lastly, be careful with aggregations. I hope my message was interesting for you today. It's certainly not for everything, and I think if you work with interesting consumer data, which more based on counts or frequencies, which doesn't have time series dynamic to it, I don't think it's a big problem. But if you work with something similar here, I'm really keen to know how do you approach those. I'll skip through this one very quick, but just want to let you know I use R in my research. Really like R and like sharing my love about R to other people. But if you're really interested to know more, or maybe you have feedback, suggestions, or criticism as well, please get in touch, let me know, and if we have time, I think we do have some time. So if you have any questions, I'll be happy to answer them now. And thank you for listening. Yes?
I'm trying to understand the rural data model. Is that a model that's applied after looking and seeing all the data, or have you got some kind of like moving window or some kind of lag saying the model is forecasting this and that's the output?
So I did quite a lot of experiments before showing you this case. So what I did first is I picked some random patterns and I split them by seasons. And I said, I'm going to take a random week, which doesn't represent holiday or doesn't represent, any disruptive week in a month. And I'm going to take a winter week and the same for summer. And I'm just going to look at it. But then I thought, maybe if I pick the customers from specific spatial characteristic, that can give me a bit of diversity of the sample. I looked through a lot of data, so the examples I gave you actually were very carefully chosen by me because I was trying to find a good distinctions, because there are certain patterns which are either impossible to predict or perfectly to predict. So I've shown you both, but this is a single customer. It's 11 days I've shown on this graph for each example. When I tried to scale that to a month, it just won't handle it. The model won't handle it really well. So it's more like experiments today. It wasn't, I don't know if that answered your question.
Okay, put it another way. Were you forecasting? How does it forecast?
Yes, it does.
You said something about it's good for a week, but not a month. Does that graph show that? Was that graph forecasting a week ahead?
Yes. So in this scenario, we learn from, so this scenario, so in the graph I've shown, it's not a forecast, okay? So that's a fitted model, okay? So what happened, I don't know if you know regression, it's like if you do regression. So what's happening is you have a data, you're trying to find the model which best describes this data.
The one before I was asking about.
Yeah. Yeah, so this one would be impossible to forecast, okay? So even though you fit your data, okay, only provided that the customer would actually replicate the same dynamic, you'll be able to make some sense of it. The other example, it's perfect. You fit your model, it can easily tell you next day because it's identical. Here, some dynamics would replicate, but if you scale it down to it's quite well, sort of, you could possibly scale maybe extra 5 days, 6 days, if the week was exactly the same by this person. And then this is my point, actually, that it's really hard to do this.
There is some data that you can't make, you could not build a forecaster on, and you're trying to work out what data you can't and what data you can build a forecaster on.
Yes, and I'm also trying to kind of say that this model, so fit into this data could work if you made it really complex, right? So if you had a separate model for this guy and a different model for the other pattern, you would be absolutely fine. But can you afford that as a data scientist to have an individual model for every single customer? So I think it's more of a challenge, something I was trying to tackle, trying to understand how would you do that if you wanted to forecast this use, how much uncertainty it will bring. Yeah.
Did the original data set include any weather information, or were you able to correlate weather information in? Because presumably temperature and wind effect obviously has a massive impact on usage. And if you don't have that in the data sets, does that not mean that you aren't able to get reliable clustering, etc., because a cold spell in Edinburgh could be counteracted by a hot spell in London? So did you have the weather information in there at all, or was that not?
So I didn't do much of it, but one of the reasons actually that I looked at quite a lot of work done on relationship between the two, and even though it seems obvious, it's actually not that much. The reason being that, so if you think ourselves, so often actually people find useful they think of their own experience with energy, right? So it's fairly cold outside, but it doesn't mean we rush to put the heating on, or it doesn't mean you necessarily will change the time you put the kettle on. Okay, so even though weather seems to have an impact, I think it'll have an impact in maybe certain areas of supply, but when it comes to the use, we actually don't change much as a response unless it's extreme. So in my case, I resort not to do that because I found quite actually a lot of noise coming from weather. So weather gives you noise, which you think will help you, but it actually starts to obstructing the pattern. And then it creates a correlation which makes you think, oh, it's because of the weather, or actually it was something else. But the interesting point is, it would be great to do that, and it's computationally, I think I would struggle. So if I had something like Kafka, you know, to put it all together for me, I think it would take me a minute, right? But there are many reasons why I chose not to. But it's certainly a very obvious one, a very interesting one as well. Yes?
Just a little addendum to that. Surely, I mean, fuel poverty is a complex interaction, which would involve a person's actual poverty. You can get socioeconomic status down to the individual street, if not house. And a person's level, things like unemployment are very important. Obviously, weather, and you know, there are kind of multiple other factors there which you could use to triangulate and get a much better answer, surely.
Yes, I think that. So I totally agree with that. And I spent quite a good year I spent to research fuel poverty, understanding how complex it is. So my example of today was actually sort of to think if you, for instance, if you're a data analyst, you know nothing about fuel poverty, and your boss comes and says, let's predict this label, you could predict it potentially with the data. But when you think about it very carefully, like you said, you know, if you think, is this a stable result? Can I actually predict that customers fuel poor? Probably not. And that's why the accuracy isn't the end of the story. And in my case as well, fuel poverty is absolutely obscure definition. Like no one knows what is it even, and people resort to income. Then they think maybe we need to have more interview approach. We need to speak to people to understand In my case, it was mainly just understanding whether customers were receiving any financial support. So you could see how vague that says already. I wanted just to open lead for potential to do this kind of things because I think government would be very interested to try this. And at the moment what they have is they sort of have the aggregates. So they have a map of the UK and they kind of know, okay, this area or this postcode sector, which is quite a huge area if you think, to analyze, may have higher risk of fuel poverty. And that tells you nothing, right? So you can't really go and know which street, you have no idea. So as a potential in the future, hopefully, there'll be more solutions and more data can come in. And I'd like to be part of it to see if you actually put that together, then your answers will be not just precise in terms of accuracy, but hopefully they will be accurate in terms of considering all these factors. And I think that's where data science comes, right? We need to work together because stuff I've shown you today, you can use that and make actions on that. But if you had an expert on fuel poverty, then saying, look, that's not, I think that would make a better environment for data science in general.
Data. Those three factors, housing quality, socioeconomic status, and actual energy use, would give you...
So it's very interesting. People talk a lot about it, but actually, whoever tried to put that together, they still struggle because you still have about 50% of variance unexplained. It's just because people are so unique in our habits, things we do. Like, I work with so many people who often suggest me this. They're like, surely the house, surely if you put this together. And my ex-supervisor, he always said, look, my street have exactly the same houses. Surely everyone has the same energy pattern. But what's key is this really weird interplay of habits, families, technology you use, lifestyle you have. What is it you like doing in the morning? And those data you'll never get. So how do we handle that? Or how do we, so my approach was, okay, let me look at the granularity of the data, try to understand certainty via periodicity. So I don't care what you do, but I want to understand how likely you are to do the same thing tomorrow. And I thought that could be maybe useful because you then rely less on this additional data, which may be harder to find or maybe unupdated. So you have one data set from 2010 and there's 2015, and then maybe you lost the picture again already. So I think we have lots of challenges right now, but I really hope in like 5 years' time, maybe, like it all will be integrated. And then this would be like this, you just do that. Sorry, go on too much, but yep, done. Okay. Yeah, thank you. Thanks. I think it's turned off.
Tonight, so thanks again to our two speakers. I think you both be hanging around.
Yes.
So if anyone has any questions for them, or Wood Mackenzie, two girls down the back can take questions on that. Or for anything on the MSc program, ask myself, John and Alterix. So thanks a million. There's still some pizza left, I think, and hands if anyone wants one. Thanks for coming. Appreciate it. Cheers.